Hey guys, it's Mr. Lancaster. Welcome back. It is Thursday, the 30th. Bam. Hope you're all doing well and having fun and staying sane and just doing well. Last time we left off on will a mountain last forever? And the answer was no. Why not? Because of two types of wedging. One of the types was ice wedging. When water gets into the crack, freezes, and then it expands and breaks it. Because if you don't remember, water when it freezes gets bigger. Just like when you put a can of soda or a water bottle or anything that's liquid into the freezer, it's gonna get bigger. Water just gets bigger for some reason. And then we have seed wedging. Seed wedging is when the seed gets into a little crack in a mountain or the asphalt or concrete or sidewalk or a building or really anything, and it gets into the crack and then it makes it even bigger and it starts breaking it up. So I was going to read you an article, and also I was going to show you a video today. I'm going to read you the article first. So let me share my screen with you. And here we are. Okay, so we're going to read this one. 2,500 tons of rock fell off Half Dome. Yes, 2,500 tons of rock. So let me go here. Okay. By the way, if you don't know, a ton is 2,000 pounds. So 2,000 times 2,500, do you know the math? Well, all you have to do is double it and then add your zero. So if we have 2,500 times 2, because we're 2,000, then what would that be? Well, this stays the same, this stays the same. This 5 doubles into a 10, right? So then this 5 is going to go to a 10, and you can't have a 10 in this one spot. So what do you have to do? Carry over. So now this 2 is a 3. But then we do 2 times 2, and which is 4. So, and then we have 4 plus the 1 on top. So again, it was just the 2.5 times 2, which is 5. And so we have 5,000, and then add the zeros. We had 3 zeros on 2,000. So we had 3 more here. So it would be 5 zeros after the 25. So we would have, let me write this down so I don't mess it up. Oh, where's my paper? 2,500, and then 1, 2, 3 zeros. Ooh, so 2,500,000 pounds of rock. That's a lot of rock. Y'all, that is humongous. And you're going to see what's so ironic here is that no one even noticed it when it fell. Like, how does that much fall and then we don't even notice it? So, Yosemite National Park in August 28th, the view of Half Dome and the Yosemite Valley on August 28, 2013, and the park in California. As the rim fire continues to burn on the western edge of Yosemite National Park, the valley floor of the park remains open. The rim fire has charred more than 190,000 acres of forest and is currently 30% contained. So I think they're talking about an actual fire here, but that's not really what this article is about. But this is a half dome. I think they call it the half dome because domes are shaped like this, kind of like a circle. Kind of like, just imagine a ball and you cut it in half and you put it on the ground. It makes a dome like that. So last week, thousands of people squeezed their way into the Yosemite National Park, and you can bet that nearly all of them spent some time gaping up at Half Dome, the park's crowning attraction. And yet, not a single one of them noticed when a 5 million pound slab slid off the face of this rock and came crashing to the valley floor. Oh, right, I said 25 million. I forgot to put the 5 there. So it's actually 5 million. So not 2,500,000, it's 5 million because we had to double it, remember? It wasn't until July 5th that a pair of climbers over halfway up the 2,000-foot cliff noticed that there was a massive section of missing rock preventing them from reaching the next place to anchor their rope. There was a big dirt outline where the ledge was supposed to be, wrote Dave Miller on the climbing website, relaying the information from his perplexed friend to a message board. Yes, it's weird that nobody noticed a 5 million pound slab of rock slid off the face of the most iconic attraction in one of the most popular national parks in the country. But it turns out huge slabs of rock fall off mountains in Yosemite all the time. Yosemite Valley, the main drag of the national park, sees about 60 rock falls a year. If you remember how many weeks are in a year, there's only 52 weeks. So that equates to about one a week, a little more actually, says Greg Stott, Yosemite's chief geologist, and you'll get to see some of these awesome falls in the video. Most of these occur due to a process called exfoliation, a result of the unique geological process that formed the valley. About 25 million years ago, the North American plate started overriding the Pacific plate. As the leading edge of the Pacific plate was pushed into the hot mantle below, it melted, sending bubbles of magma up through the layers of continental crust. Half Dome, El Capitan, and many just lost it. Sorry. Half Dome, El Capitan, and many of Yosemite's other peaks began as these bubbles called intrusions. The bubbles didn't actually reach the surface, but over time they were exposed as ice age after ice age sent glacier after glacier carving through the nascent Sierra Nevadas. Softer rock cut away, leaving the tough granite intrusions sticking out. Half Dome among the largest and most striking. One second. The last glaciers retreated about 15,000 years ago. Since then, the dominant process shaping the granite extrusions of Yosemite Valley has been exfoliation. This is exactly what it sounds like. Thin flakes of rock sloughing off. Rock will expand or contrast as it heats and cools, says Stott, Yosemite's chief geologist. That means it swells out when the sun is up and it shrinks in the shade or nighttime. But the heating is never even because the sun hits different parts of the dome at different times, or sometimes not at all. The inner layers of the half dome don't get nearly as hot, so the expanding outer sections start to form inner cracks that run parallel with the dome's face. So basically what happens is that the inside of the rocks is really cold. And then the outside can heat up a lot because there's a lot of sun getting to it. Whereas the inside, it can't. So when rock gets really warm, or just warmer than how it is really cold, because the inside of the rock can be very, very cold. If you've ever been underground or in a cave, it's really cold. So what happens is it just gets so much warmer on the outside, it expands. And then when it expands like that, I don't know if you've noticed, but rock it's not stretchy, right? It's really hard. So there's nothing stretchy about rock. So if you take a rubber band and you stretch it, it's going to go back to how it was, right? But if you take rock and you kind of hit it and then it moves and it kind of stretches out of its normal size, it's not going to go back as easy. So what happens is when it gets hot like that and it stretches, it doesn't quite go back, and there's these cracks that are left over, and it just doesn't work as well. So that's that, and I wanted to show you this awesome video. So let me show you this video from Yosemite National Park from Safe YouTube. You're gonna like this. Let me share my computer sound. There we go. There we go. There we go. Okay.
This is actually a really interesting viewpoint to view.
Lord have mercy, you would not see Mr. Lancaster that high up. No, no, no. You won't see me 10 feet off the ground. That is not for
The
me.
run-out zones.
You know, actually, I wanted to be a professional rock climber, but more of a boulderer, a professional boulderer. That means you climb really hard routes that are much smaller. They don't go as high up. So it's kind of like when you run, you can sprint, which is really hard, but you can't sprint for long. Or you can run nice and easy for a long time. And some rock climbers, they'll have an easy route and they'll go really high up for a long time. And then some will do what's called bouldering and do that. I was too afraid of heights to climb, but Yosemite is a very big place where rock climbers come and they climb because of that. And actually, one person had climbed what's called El Capitan, which is about 4,000 feet, or 3,000, I'm sorry. And he climbed it in 4 hours. It took him 4 hours, and he climbed it without any ropes. Please don't ever do that. I don't understand how he did it. I would probably have died in the middle of that because I'd be so worried about falling. And I just think it's kind of, one, it's kind of awesome, and two, it's kind of crazy, and just don't do it, okay? Anyway, let's continue with this. So this guy is using a belay. This is called a belay device. A lot of rock climbers use, but I don't think he's a rock climber. I think he just works with a part.
For rock falls from Glacier Point. Usually we're looking either across the valley over at Glacier Point, or we're down at the bottom looking up. And those are valuable views as well, but this is really useful to be able to be up here and look down. And from right here I can see run-out zones for about 5 different rockfall events that have occurred, in the past decade or so. The cliffs are eroding very slowly, grain by grain, all the time. But when suddenly, a piece of the cliff that's 200 feet wide and 100 feet tall and 20 feet thick just spalls off the cliff and falls 1,000 feet to the valley floor and breaks up into all these pieces, that's a really different style of erosion. When we look around Yosemite Valley, we see abundant evidence that rockfalls have been occurring here for thousands of years.
Oh, he's rock climbing. He's bouldering.
Yosemite Valley is a glacially carved canyon, and since glaciers retreated about 15,000 years ago, rockfall has been the major force shaping this landscape.
We don't always know what causes a rockfall in a particular event. Sometimes it's obvious in that there might have been a large rainstorm or snowstorm that then caused a lot of seepage, and so we surmise that that seepage must have caused a rockfall. It's not always the case. Sometimes rockfalls happen without any known trigger, so it could just happen on a nice, bright, summer, sunny day.
We had decided to rent bikes to ride around the valley. We were only here about an hour and heard this loud, thunderous roar, and couldn't tell where the sound was coming from, and looked around. And
so just so you know, it said that he was a geologist. So a geologist is someone who studies somewhat rocks, but more things like landslides and earthquakes and erosion like this. So it's their job to figure out, to try and predict when they are going to, when these rock slides are going to fall. Why is that important? Well, it's important because if someone's there climbing the wall and this rock breaks off, well, then they could, fall hundreds of feet, and they're not going to survive that. They would die. So it's their job's super duper important, and it's a really, really cool job. And it's something that I think a lot of people would like to do. You may want to do it. It may be something you like. It's something cool to consider. And yeah.
Happen on a nice, bright, summer, sunny day.
we had decided to rent bikes to ride around the valley. We were only here about an hour and heard this loud, thunderous roar and couldn't tell where the sound was coming from. And looked around, and I saw rocks falling off the wall over to my right. Whoa, rock fall, look. Had to get my camera off the bike as quickly as I could. That's why the footage was a little shaky. Had to take the wide-angle lens off of it, and was lucky enough to catch the third rock fall. Look at that piece.
In the particular rockfall that was captured on video, you can see a rock slab detaching from the cliff face, sort of skipping down the cliff face, hitting a prominent ledge, breaking up into a bunch of pieces. And some of those individual pieces are 40, 50 feet on a side. And those pieces then are free falling through the air, spinning on their way down. They fall several hundred feet, and then they impact the talus slope at the bottom. And some of those huge boulders will be moving down the talus slope at 40, 50 miles an hour, snapping large trees like matchsticks and going all the way down to the base of the talus slope and the valley floor.
We're standing at the base of the rock fall that happened on August 26th of last year, 2009. And this is one of the rocks that fell from it. I thought they were about that big, you know, because we were about, I don't know, half mile away. So they didn't seem that big. But now looking at it, they're huge. It's amazing to think that it came down from up there and then bounced, I guess. It must have bounced, right?
And prior to August of 2009, this slope had large oak trees on it. But when several thousand tons of rock came down off the cliff and landed in this area and then moved down the talus slope, those boulders basically wiped out all of the trees that were on this slope. And this talus slope leads right down to the floor of Yosemite Valley, and just beyond the edge of the talus slope is the Iwani Hotel. If these rockfalls were occurring in a remote valley, they would be of scientific interest only. But because these rockfalls are occurring in Yosemite Valley, a narrow valley with nearly 4 million visitors a year, they are more than a spectacular natural process. Depending on where and when a rockfall occurs, it can have potentially serious consequences. In 1971 and 1972, there were two large rockfalls that came off the face of Elephant Rock.
Ooh, Lord have mercy. Look how close he is to that cliff. Would not be Mr. Lancaster.
This was the impact area for the March 1987 Middle Brother Rockfall. This is the impact area for the July 10th, 1996 Happy Isles Rockfall. This boulder here that I'm standing on, roughly 400-ton boulder that came down in October of 2008. So this boulder here is an old rockfall boulder, and you can tell that this is an old rockfall boulder because it's covered in lichen and moss. It's not a fresh boulder. Now in contrast, this boulder here is fresh. It has no moss or lichen growing on it. And this boulder is just like those other boulders that came down from earlier rockfalls. The difference is when this boulder came down in October of 2008, these structures were here in Curry Village, and the consequences of that are obvious.
A scary situation hitting visitors at Yosemite today. For the second time in as many days, a rock slide has hit the park's Curry Village area.
We are getting some eyewitness accounts of that rock slide that hit this morning, sending people running and crying in fear, and there are some unconfirmed reports of injuries in that area. Now, we got some pictures from KCRA3 Live. Copter 3 HD was over the scene of that rock slide this morning that took place at about 7 o'clock.
Our primary concern is saving people's lives. 15 people have died from rockfalls in Yosemite National Park in the last 150 years. And that's not an insignificant number. It is much smaller than the number of people that have died in Yosemite's streams and rivers, and it's certainly much smaller than the number of people that have died in traffic accidents. But one big rockfall at the wrong place and the wrong time could dramatically increase that number, and that's why we are focusing on learning everything we can about rock falls using laser scanning, computer modeling, monitoring of the cliffs. But the scope of trying to understand all of these complexities and all of these different rock faces to a point where we can start to predict rock falls is going to be really challenging.
Predicting rock falls is a very difficult scientific question to go after. It's similar to predicting earthquakes. You know, rock falls can happen anytime, and so we're interested in determining how often and when and potentially where.
So much of what we know of the Yosemite landscape, the iconic cliffs of El Capitan and Half Dome, the forested talus slopes, the big boulders out on the floor of the valley, all of these features owe their existence to rock falls. And rock falls have been occurring in Yosemite for thousands of years, and they will continue for thousands more.
All right, guys, that was it. I hope you enjoyed that. That was really awesome. That is such a cool job, a geologist. Geology is the study of the earth. So if you ever want to do that, something like that, just study, you know, how long the earth's been here, what it does, what it's going to do in the future, predicting it. That's what geology is all about. We don't know all the answers, and that's why we have scientists. So we learn and we grow and we know. So we just learn more about these things, and it's so cool. You know, some people might want something like some people may not want a job like that, but some people will probably it's really awesome, really cool for them. So yeah. All right, guys. Well, good to see you. I'll see you tomorrow. Bye.